From laws of motion, problem number 5 in problems. So the question is, a man in a lift feels an apparent weight W when the lift is moving up with a uniform acceleration of 1 by third of the acceleration due to gravity. If the same man were in the same lift now moving down with a uniform acceleration, that is 1 by 2 of the acceleration due to gravity, then what is his apparent weight? Apparent weight means it is an imaginary weight. So while we are moving with a lift or upward or downward, sometimes we are feeling like that. When we are moving, when the lift is moving upward direction, our weight is looks like increasing, and sometimes when we are moving downward in the lift, so our we feels like that we lost some weight, that whatever we lost when it is moving downward and whatever we gain when it is upward, that is nothing but apparent weight. Apparent weight means it is not actual weight, imaginary weight. Okay, so like that, here we have a one lift. For suppose this is our lift. Okay, so in this lift there is a one man. Okay, so this man is standing on the in the lift. Then weight of this is nothing but here mg. Weight of the lift means, and man is acting downward, mg. And opposite to this there is a normal reaction is acting, that is r1. Okay, so whatever the force acting on this surface, and that is nothing but here mg because of the gravitational force. And normal reaction, that is it is action, and this normal reaction, so that is r1 I am taking, or you may take n1 also, that is okay. So then our lift is moving upward. When lift is moving upward, so the acceleration is in the direction of upward. So that's why here this is mg acting downward and normal reaction upward, and the resultant acceleration of the lift is also upward direction. Okay, so here I'm writing down that when lift moves upward, acceleration is given here. Acceleration is 1 by third of gravitational acceleration. So that is equal to g by 3. This is the acceleration of the lift when lift is moving upward. From Newton's second law of motion, from Newton's second law of motion, the resultant force is equal to, here what is the resultant force, that is it is having some mass into a, and this is our lift is moving upward direction. When it is moving upward direction, this r1 is greater than mg. So that's why here I am writing that is r1 upward force minus downward force, that is mg. Okay, so r1 is greater than mg, that's why our lift is moving upward direction, and the resultant one is mass of the lift and acceleration a of the lift. This is our mg is r1 minus mg is equal to ma. Then from this r1, this is normal reaction, it is equal to mg plus ma. Here this mg I am taking to this side, and that is equal to mg plus ma. And there I am taking m is common, if we are taking m is common, this is g plus a, okay, and that is equal to this r1 is the normal reaction. Normal reaction is nothing but n, that n is equal to mg. Here in this case I am taking it is r. So it is mg means it is weight. We call it is weight of the man which who is inside the lift. So that's why W1 is equal to, that is m of g, it is as it is, plus a is equal to already given here, that is how much, g by 3. Okay, so that is W1 is equal to, or it is W. So this is W is equal to m of, this is, if we are taking 3 is the LCM, 3g plus 1g, that is equal to 4g. This is W is equal to 4gm by 3. It is equation number 2. So like that, okay. Same, when lift is moving downward direction, when lift move downward, okay, what happens there? Here, this is our lift, okay, weight of the lift is acting downward direction, and here our the man standing here in the lift, and normal reaction it is always upward. So here I am taking r2, and our lift is moving downward, so the resultant acceleration is downward direction. Okay, so when it is moving downward direction, the acceleration of the lift is given here, that is half into gravitational acceleration, that is equal to g by 2. Okay, from same Newton's second law of motion, Newton's second law, okay, resultant force. What is the resultant force here? Lift is moving downward means this mg is greater than r2. So that's why mg minus r2 is equal to, resultant is the mass into acceleration. Here we want to r2, so this r2 I am taking to that side, that is r2 is equal to, here it is positive, then this is I am taking to this side, that is mg minus ma, and this r2 is nothing but weight of the man when he is moving downward direction. So this is m of g minus a, okay, then it is equal to m of g as it is, a is equal to g by 2. So that is equal to, this is equal to here m of, if we are taking LCM, this is 2, and here it is g, 2g minus g, okay, that is equal to 2g minus g, that is m of g by 2. Okay, this is our w dash. Now we want to find out this w dash, so that is, okay, w dash is equal to mg by 2. Okay, so w dash is equal to, from this one equation number 1, w is equal to, from equation 1, w is equal to, sorry, gm is equal to, from this gm is equal to 3w by 4. Substitute in equation in w dash, then W dash is equal to, here in the place of mg by mg, we are writing this one, that is 3w by 4 by 2, and that is equal to 3w by 8. This is our answer.